We're still talking. We're talking hypothesis tests, and on Monday I kind of laid out the logic or the ideas going behind hypothesis tests. And today I will kind of formalize the steps that you go through in order to do a hypothesis test. Okay, and so today the hypothesis test we will look at will be hypothesis tests for P, the population proportion P, based on one sample. Okay, on most likely tomorrow we will look at hypothesis tests for P1 and P2 based on two samples, but today we will look at the case with just one sample. Okay, and there are four stages or four steps. Four stages in doing the test. Okay, and we will say these are, all right, make hypotheses. Followed by a little bit of preparation. Calculation of the p-value. And the last is make a conclusion based on the p-value. And then the calculation step itself can be broken down into further steps. But these are kind of going to be the overall steps that or stages that we go through when doing a hypothesis test. Once again, the big picture is we ask, what is the probability of our data? Is it likely for us to observe our data? Is it does our data and our reality and our expectation, do those line up, meaning it's quite likely to see our data? Or is it something different, where the expectation and the reality are different and it's unlikely to observe our data, right? So big picture, we create a hypothesis that shapes our expectation. And we ask, how different is the reality or our observation from our expectation? Okay. And the way we measure this is we ask, what is the probability of observing our data? And if the probability is high, probability of the data is high, that means, we do not reject our hypothesis. And on the other hand, if the probability of our data is low, we do reject the hypothesis. I'm hoping this is feeling kind of familiar from what we talked about on Monday. Okay, So try not to lose sight of the big picture as we go through each of these steps. Because sometimes when we get focused on the steps that we're doing, which is important, we got to learn these steps in order to do the test. Sometimes it's easy to lose sight of the big picture idea of what's happening. And the big picture idea is we want to know, is the probability of our data high or low if we're making this assumption to form our expectation. Okay, so let's start off with part 1, the hypotheses. Okay. And so we start off with the creation of a null hypothesis, which we write as H0. H0 is our null hypothesis. And in this case, we are doing a hypothesis test for P based on one sample, and we say P is equal to some number. Okay, some number, and that value is going to be called P0. Okay, so the null hypothesis states that P is equal to some number P0. And then the alternative hypothesis HA, this is identical to the null hypothesis, except we replace the equal sign with a not equal sign, or we say P is greater than P0, or P is less than P0, okay? And our choice of not equal, greater than, or less than depends on the question written. So, for example, let's say we said, someone claims that, the bucket of M&Ms is 17% green. Okay, so someone claims that the bucket of M&Ms is 17% green. Okay, you take a sample of data, take a random sample of data, and a random sample of data, let's say, is 120 pieces, and I don't know, 25 pieces are green. Okay, and we ask, does this provide evidence that the proportion green in the bucket is higher than 17%? Okay, and so in this case, the proportion green, the question is asking, does this provide evidence that the proportion that is green is higher than 17%? Okay, because of this, our null hypothesis will be that P is equal to 17%, and the alternative will be that P is greater than 17%. Okay, if this word were different, if it says, does this provide evidence that the proportion green in the basket in the bucket is different from 17%? If it said different, we would use a not equal sign. Or if it said is less than 17%, then we would use a less than sign, or something like that, okay? So our choice of the not equal sign, greater than, or less than sign depends on the question written, okay? Maybe it's also important to note that the null hypothesis always has an equal sign. Okay, and so if the claim says somebody claims that the proportion is greater than 18%, okay, then the greater than 18% will go into your alternative. The null hypothesis is always that it's equal, okay? That's the only way we can do tests. We can only do tests if we are claiming that it's equal to some value. All right, is that okay? So our choice of not equal, greater than, or less than depends on the question here. So this tells us to use greater than in the alternative hypothesis. Okay, so that's how we set up our hypotheses. You always have an equal sign, and so we say P is equal to some number P0, and in this case, you know, P is going to be 17%. The alternative hypothesis is identical, except we change it to not equal, greater than, or less than, depending on how the question is written. Okay, once you have your hypothesis, the second part will be preparation. Okay, preparation consists of a few parts. One will be identify key values in your data. Okay, and so in our case, for a hypothesis test for P with one sample, the values we need P0. P0 is the value from our null hypothesis. We need N, which is the sample size. And we need P hat, which is equal to X divided by N. That is the sample proportion. Okay, so those are the key values you need to identify. We also need to select a significance level. Okay, the significance level is called alpha, which looks like that. It's the kind of the Greek letter equivalent of the letter A. Significance level alpha. This is the significance level is kind of a line in the sand that that we use to say the probability is large or the probability is small. Okay, so again, in the big picture, we said the question was, is the probability of our data big or small? Okay, how do we decide when the probability of our data is big or when the probability of our data is small? We just kind of draw a line and we say if it's bigger than this number, if it's higher than this number, it's going to be considered big, and if it's lower than this number, it's going to be considered small. Okay, it's like, you know, are you tall enough to ride the roller coaster? There's just kind of an arbitrary line. Well, not arbitrary, it's based on safety. And you know, if you're taller than it, you know, you can ride, and if not, you know, you can't. And so, you know, that's like a problem when you're in 4th grade. And that's what we have here. Okay, significance level alpha. If it's bigger than this, you know, it's going to be considered large, and if it's smaller than that, it's not. Okay, this might be specified in the problem. It might say use something like use a significance level of 10% or use a significance level of 1%. But sometimes it is not, and if it is not specified, then you can assume that alpha is 5%. So if it's not specified, you can assume alpha is 5%. So, in the United States, most things, the minimum age required, for to be an adult or whatever is 18, okay? And we have a few exceptions, right? So most of the time, if you're 18, you're allowed to do whatever, except for when it comes in California, if you want to smoke or if you want to drink, then you have to be 21. Okay, we have a few exceptions, and then going to rated R movies is 17. But pretty much, if it doesn't say something and you're like, am I legally allowed to do this? If you're over 18, the answer is probably yes. Okay, and otherwise it'll probably specify clearly about whether or not it's allowed. Okay, in the same way, if it's not specified in the problem, assume it's 5%. This is kind of the established marker, but it might be different. Okay, I think Canada's drinking age is 19. So, all right. And then lastly, we will check conditions. Check conditions to use the central limit theorem. And those are what? The random condition, random independent, large sample, and big population. All right. Now, for exams, so when it comes to exams, this is an important step to check the conditions to use your central limit, to use the central limit theorem. That's an important thing that you have to do. However, when it comes to exams, it's hard to write questions that didn't feel like I was setting up traps, okay? Because I could ask a question, what's the p-value for this problem, or find the standard error, but then it was like, oh, just kidding, it was a trick question. You were supposed to check the conditions, and you're going to say that the central limit theorem is not allowed. I felt like I was writing traps in that way, so like the midterm, I'm going to have just separate questions where you check the conditions, okay? Separate questions for checking the conditions. And when it comes to doing actual calculations and going through the process of a hypothesis test, you can assume that the conditions are met, okay? So for exams, the problems will have conditions met. Except for that one section where I'm going to say check the conditions, okay? But other than those problems where the conditions are met, except where I explicitly have you check, where checking conditions is the only part of the problem, okay? Now we'll just say for the exams, the problems will have the conditions met. Yeah, that's fine. Okay. Otherwise, it felt like I was writing traps. All right. Here is part 3, the calculations. Calculating the p-value. Calculating the p-value itself can be broken down into a few parts. So I'll have step 3a, which is going to be find the standard error. Okay? The standard error is the square root of P0 times 1 minus P0 divided by n. They're all kind of like variants of the same. So here we have P0. P0 again is the value in your null hypothesis, right? Okay, once you have your standard error, the next part is get a z-score. Z is going to be p hat minus P0 divided by the standard error. It's kind of in the form observed minus expected. We're comparing the reality versus our expectation divided by the standard error. All right. So once you have your z-score, you're going to look up the z in the table to get a p-value. Get your standard error, get your z. Now you're going to look up z in the table to get a p-value. How to get the p-value depends on the alternative. Depends on the alternative hypothesis. Okay. So if the alternative hypothesis has a less than sign, okay, then the p-value equals the area to the left of z. That's if you have a less than sign. If the alternative has a greater than sign, then the p-value is equal to the area to the right. And if the alternative has a not equal sign, then the p-value is equal to 2 times the tail area. Now what is the tail area? The tail area is the area going away from 0. So if z is negative, it's to the left. If z is positive, it's to the right. Tail area is the side going away from 0. Meaning, that is to say, that tail is to the left. If z is negative, and the tail area is to the right, and z is positive. Okay. So if the p-value, if you have a not equal sign, then the p-value is 2 times the tail area. So these are the ways we get our p-value. Is everyone still with me okay? All right, and then the last part, stage 4, this will be make your conclusion. And so what we do is we compare the p-value, compare it to alpha, significance level. Okay? If the p-value is greater than alpha, okay, this means the probability of our data is considered to be large. I don't need to put that in quotes. Okay. If the p-value is greater than alpha, we consider the probability of our data to be large. This means we have no reason to doubt the hypothesis or the assumptions we've made. Okay, so the summary rule is if the p-value is greater than alpha, do not reject the null hypothesis. And on the other hand, if the p-value is less than alpha, this means we consider the probability of our data to be small. We consider the probability of our data to be small, and this means our data is unlikely to happen, unlikely to appear if, if the null hypothesis really were true. And so the fact that we did see this data means we got to kind of side with reality and say that the assumptions we made to create our expectation, those assumptions were wrong. Okay? The fact that we see this data indicates to us that the assumptions made to create our expectation were wrong. Okay, and so the concluding thought here would be if the p-value is less than alpha, we reject the null hypothesis. So if the p-value is larger than alpha, we do not reject the null, and if the p-value is less than alpha, we do reject the null hypothesis. All right, is this okay? Let's work through an example then, and maybe I'll sprinkle a few clicker questions along the way here. Let me save this. Go back here. So we'll start. Okay, so we'll start off, this will be our question here. So someone claims that the bucket of M&Ms is 17% green. You take a random sample of data, 120 pieces, and 25 pieces are green. Does this provide evidence that the proportion green in the bucket is higher than 17%? Okay, and then so we've already established the hypotheses. Okay, so part one, setting up the hypotheses. This has already been done. So our null hypothesis is P is equal to 17%, and our alternative is that P is greater than 17%. Part two, I will just go ahead and I'll just say the conditions are met. We will use alpha equal to 5% because it's not specified in the problem. And then when we gather our data, we need P0, we need N, and we need P hat. So P0 is the value from our null hypothesis. So P0 is what? 17%, 0.17. N is our sample size, 120, and P hat is 25 divided by 120. I don't know what that is. $25, 0.2083. I need to move this down. Okay, so that's what we do. All right, let's okay, part three will be do your calculations, and then I guess I'll make a clicker question. So the clicker question will be, what is your z-score? All right, and so our answer choices, and make up some numbers here. I guess we'll just do positive versions of these. Okay, we'll go ahead. We'll just keep it easy. We'll say these are your answer choices that we want. Negative, 1.12, 1.03, negative, or positive. Positive versions here. Okay, so go ahead and get your, try to find your z-scores here. And then we'll check. So if you want to talk to your neighbor, that's fine. We'll let this run for a minute. All right, let's take a look at how you guys responded. And yes, that is correct. Okay. So what we do here is we get our standard error. The standard error is the square root of p0 times 1 minus p0 divided by n. Okay? In this case, we use p0. We don't use p hat. So it's going to be 0.17 times 1 minus 0.17 divided by 120. You get some number there. Okay? And then the z-score is going to be p hat minus p0 divided by our standard error. So in this case, I have 0.20833 minus 0.17 divided by the standard error. And when I did this, I got 1.117 or something like that. So this is going to round to 1.12. So our answer choice is D, right there. So this is our z-score. Let's we will continue on. And so if your z-score is 1.12, the next part of the question is, what is your p-value? And I need to pull up my z-table. Okay, so z is equal to 1.12, and so now the next question is, what is the p-value? And we'll also make this a clicker question. And your choices are okay, so go ahead and decide what the p-value is. The question is, what is the p-value? What is the p-value? So we found in the earlier part of the step, right, is we got our z-score. So based on the z-score, what is the p-value? So if you need to refer back, and on this slide it says the last part is once you get your z, you're going to look up the z in the table to get your p-value. And here are the rules. And it depends how you get the p-value depends on the alternative hypothesis. The original question says, does this provide evidence that the proportion of green in the bucket is higher than 17%? Okay, so that's going to determine your null and alternative hypothesis. And this will decide. Okay, sorry. All right. Wait, what's going on here? I don't have the answer up there? What did I do? Oh, I looked at the wrong number. Okay. All right. All right. All right. Just kidding. Okay. All right. See, this is... Okay, so what am I looking up? 1.12, yeah, okay, 0.8686. All right, so I got to change all of my answers here. All right. Yeah. My life is so hard, guys. All right, okay, so I got 8686. Okay, 1 minus that is 1314. 2 times this is 0.2628, and 0.8686 times 2 is 1.7372. Okay, there we go. That's better. And now make your decision on what the p-value is. Okay, do we all get our clicks in? Okay, I'm gonna hit stop here. Okay, and yes, B is the correct answer. So the way we do this is we look at the null and alternative hypothesis. The null is that P is equal to 17%. The alternative is that P is greater than 17%. So the fact that I have a greater than sign here, greater than sign means p-value is equal the area to the right of z. All right, and so when you look up 1.12, you find the area to the left is 0.8686. This is 0.8686, which means the area that we want over here is 0.1314, and that's the part that we want. We want the area to the right. Okay? If the alternative has a not equal sign, then the p-value would be 2 times our tail area, and our answer would be answer choice C. Okay. If the alternative had a not equal sign. All right. Is that okay? So far, so good? Okay, and so in the conclusion, what we do is we take our p-value, part 4, our conclusion. So we found our p-value is equal to 0.1314. We compare this to alpha. We said alpha is 5%. And so we have our p-value is greater than alpha. Okay? And so what we say is that if the bucket is truly 17% green, okay, meaning that if the null hypothesis is true, then it is possible for a random sample of M&Ms to be, 0.2083 green. Okay, and this kind of random sample happens with a probability of around 13%. And so this would be an indication that what we observed is not very, very different from what we expected. Okay, so what we observed, or the reality is not starkly different from what we expected. So in conclusion, we conclude not to reject the null hypothesis, and we would say we do not have evidence that the proportion of green M&Ms is higher than 17%. We do not have evidence that the proportion of green M&Ms is higher than 17%. Okay, so that was us walking through the entire hypothesis testing procedure for a single proportion. We'll take a look at dealing with two proportions on Friday. Okay, have a great day.